Okay, so let's look at number 9. Number 9, and that's on page 93. All right, it says we have a physics book slides off a horizontal tabletop with a speed of 1.1 meters per second. All right. So as usual, y'all, remember what I always said, you draw it. Now look, let's go ahead and draw our x, y axis. Right there they are. This is y, this is x, okay? So it's going to be there, all right? So the book is here, and it slides off, right, and does that right there, okay? All right? And it slides off a horizontal tabletop with a speed of 1.1 meters per second, okay? Now, let me ask you something. Just as it slides off, that speed is what? Is that Vx or Vy? Well, it's moving horizontally. All right? You say, how'd you know that? Because it was moving horizontally. And it just comes off, right here, just as it comes off. All right? So what would be the y component of the velocity, initial? Is it going up and down? It's coming off horizontal, right there. What is its y component of velocity equal to? No, velocity, not acceleration. Velocity. 0. All right? Now, what will be the x component of its acceleration? Once it comes off, is anything else acting on it? Is anybody else pushing on it while it's flying through the air in the x direction? So it's what? Remember what I said? That neglecting air resistance in the x direction, the acceleration of an object or projectile is what? That's this conceptual stuff we've got to remember now. In the x direction. What is its y acceleration? Negative 9.8, right? How do you know it's negative, Ms. Shields? All right, look, xy. xy, it's going down below. It's going in the negative y, right? Okay, okay? Now, do you see what I just did there? You have to label all the parts of the problem before we start trying to figure out what formula and all that stuff, okay? You got to draw it and you got to label it. You got to think conceptually. Okay, conceptually in the x, no acceleration. Conceptually in the y, negative 9.8. Okay. Y velocity initial is 0. Y velocity, x velocity is what it told us, 1.1. Okay. All right. Ignore air resistance. Find the height of the tabletop above the floor. So we want to know delta y. All right. Well, now look. Okay. Well, you say, was that going to be negative or is it going to be positive? Well, since it said above the floor, then this is going to be y initial of 0, isn't it? And so y final is really what we're looking for. But now look, can I combine it? Can I combine it and just say delta y? Yes. Okay. All right. Oh, and I forgot the time. Why didn't y'all say something? And it took how long? 0. What? 48 seconds. Whew, almost forgot that. There we go. Right? It comes off and it strikes the floor 0.48 seconds later. Okay? All right. Okay. All right. Now notice, we know initial y, we know final y. We don't know final y. We know time, we know accelerations, we know initial velocities. Okay. Now notice it asks for y. How high? So what kinematic can I use? Well, remember you only got 4. And remember what I told you about the y, for the y direction, just change the x's to y, and in the place where acceleration was, put a negative g, right? Put negative gt or negative 1/2 gt squared. Remember that? And remember I also told you don't do negative negative. Remember the negative's there to tell you that gravity's already negative. You don't put another negative in, okay? You understand what I'm saying? All All right, could we use this equation? Look at your kinematics. There's only 4 of them now. There's 4 in the x, and guess what? The 4 in the x are the same in the y. You just change it to y, and you change the acceleration to negative g. All right? Okay? Could we use this one? Now, look, we can write it one of 2 ways. We can do it this way, like your book shows you. Or we could say plus 1/2 AT and put negative 9.8 for A. That's the same thing. That's the same thing. Okay? Okay? So look, now watch. Are you watching? What's initial y? And by the way, that's y in the velocity in y direction. What's initial y? 0, it's gone. What's initial velocity in the y? 0, it's gone. So what are you left with? Okay. And you say, well, now, Mr. Shields, is it positive or negative? How can you get rid of that negative? Well, here again, it all depends on which way you want to look at it. Okay. If you're going from here down, then negative times, then y final is negative. But if you're going from here up, notice that gravity is negative going which way? Down. So if we're going in the opposite direction of gravity, we have to put a what on it? If we're going up, it's positive. So here's one of those places where you can just drop that negative off. Since we're only looking for the maximum height, okay, because it's going straight down. Well, you say it's following a parabolic path. Yes. But remember, that's only half the parabola. It's not full projectile motion. Okay? So plug and chug, y'all. 1/2. What do we got? 9.8. And I've dropped the negative. Why? Because it wanted to know how high above the floor. Okay? And we got 0.48 squared. And what do we get? 1.13. Is that right? Does that look right? Okay. All right. So that's what, A? All right, what's B? The horizontal distance from the edge of the table to where the book strikes the floor. All right. Okay. All right, y'all. It says horizontal. In other words, from here to here. Right? It wants to know delta x from here to here. You follow me? Do I need to redraw it? All right. It wants to know that right there. Okay? All right. So B, all right, y'all. What kinematic will fit perfectly? All right, what is x initial? Well, x initial is 0 meters because that's starting point. Okay? So we're looking for x final, aren't we? Yeah? Okay. So could we use this kinematic right here? Could we? Okay, y'all, are there any components that we can drop off of this? Parts we can, are there any parts we could get rid of real easy? All right, y'all, what was the initial displacement? 0? Well, wait a minute now. What was the x acceleration? 0. So x final is equal to what? 1.1 meters per second times 0.48 seconds. And we get a distance of what? 0.53 meters. Yeah? All right. Is that good? All right, now let's look at part C. All right. This is where it gets a little more interesting. The horizontal and vertical components of the book's velocity and the magnitude direction of its velocity just before it reaches the floor. Okay. All right. Okay. Well, we know what? This is what? 9C. We know that just before it hits the floor, all right, books here, comes off, boom, right there. Okay. We know that the initial velocity in the x is what? 1.1 meters per second. And what do we know about that? That is what? Constant, isn't it? Okay. We know that initial velocity in the y is 0, in the y, 0 meters per second. All right. Do we have a final y? Notice what it's asking. It says, what are the horizontal and vertical components? So C is wanting what? Velocity what? Velocity final in the x and velocity final in the y, isn't it? All right? All right. Well, y'all, we already know velocity final x. It's 1.1 meters per second. And how do you know that, Mr. Shields? Because it's neglecting air resistance, it's constant. Well, how will I find y? Well, you remember this little kinematic right here? So plug it in, we got 1.1 meters per second. Oop, nope, sorry. 0. All right. So we got V final in the y is what? 0 meters per second minus 9.8 meters per second squared times what? 0. What? 48. And so we get negative what? 4.7 meters per second. Yeah? .7 meters per second. Okay. All right, any questions about that? All right, so my y component then is what? Okay. So how do you know? Draw your coordinates. Notice that's in a negative y. Right? And if you look at it displacement-wise, your initial displacement is 0. Your final y is very big negative, isn't it? So you got a negative minus 0. And that's how I know it's negative velocity. Okay, and that's how I know it's right. Okay, now, what's the next part? And the magnitude and direction. Okay. All right, look. I've got my X. I got my Y. How do I find magnitude? Or I just should say velocity is equal to what? Square root of the squares? 1.1 squared plus negative 4.7 squared. And what do we get? 4.83 meters per second. Now what if I said it this way? What is the speed? Find the speed and the direction. Speed, magnitude, same thing. Because you say, how do you know? All right, because what is speed? What kind of quantity is it? The scalar or vector? Speed. It's does speed have direction? If I say 50 miles per hour, is there any direction there? That's speed. In other words, it has magnitude only, right? Okay. So if I say speed, then I'm asking for magnitude. But then we got to do direction. And remember, how do we do direction? Y over X. So watch now, negative 4.7 over what? 1.1. And what do we get? We get a negative 76.8 degrees. Negative 76.8. All right, let's draw our coordinates. X and Y. Where would that be located? Notice my Y is negative, my X is positive. Would that be, let's see, 4.1. Would that be something like that right there? Now, I've got to find my angle. Listen, you don't give me negative 76.8 on the test. That's wrong. Okay? I want you to show me that you know for sure what quadrant that's in. You say plus 360, and that's a negative angle. So in other words, we end up subtracting from 360, don't we? Yeah? And we get what? 283.2? And that's the angle I want to see. Does that sound right? Okay, well look. Your X component was what? About 1.1. But your Y component was what? 4.83. So it should be farther. In other words, the line should be more downward than outward, right? Yeah? Your Y is what? 4 times your X? More than 4 times. Right? It shouldn't be way out here. It should be way down here. That makes sense. Yeah? This Shields, I didn't know we was going to be doing graphing. Oh yeah, we're going to be doing graphing. All right. Okay. And then it says draw the X versus time, Y versus time, and velocity versus time graphs. Okay. Okay, so what would X versus time looks like? Okay. All right, X versus distance versus time, X versus time. All right, so as the displacement in the X direction, it's getting more positive, isn't it? Remember it said how far. So that should be positive, shouldn't it? All right, it was what? There's no acceleration in the X direction, so that means what? That velocity was what? Constant. So should it look like that right there? Yeah? Does that make sense? Now let's think about it again. We got constant velocity. What would the velocity versus time graph look like? Something like that right there? Yeah? Oh, velocity in the x. Almost boo-booed there. All right. Now, what's the other part we had to look at? What's the y versus time? Okay. All right. And it's falling with constant acceleration, which means what? That the velocity was increasing at a constant rate, but it's becoming more what? Negative? So would it look something like this? Lord, help me draw this right. Would it look something more like that? Because if I square time, what happens to that line? It becomes a straight line, doesn't it? Yeah? Mm-hmm. All right, what else we got to do? What about velocity in the y? Okay. All right. What was our velocity? Negative? Going to look something like that? You say, how do you know it's a straight line? Making an angle with the x-axis. All right. Well, what would the acceleration in the y versus time look like? Is it constant? Gravity constant? Would it look something like that right there? That makes sense? So graphs can tell us a lot. Okay? Okay, all right, I hope that helps. All right, now, so we will come in.